by a conventional VOR ground station are in phase on magnetic radial what? In phase. Very important words. Okay, now in the previous video lectures, we have come across questions in which they have asked about these two signals being out of phase with each other. And now in this question, they have asked that they are in phase, and that happens at what bearing? So let's touch upon some basics. This is your VOR station. I have also explained this in the previous video. Nevertheless, this VOR station will transmit two signals, one of them being the reference signal, which is oriented in the magnetic north direction. Oriented in the magnetic north direction. The second signal is your variable signal. This variable signal rotates around the VOR station full 360 degree. Okay, constantly, continuously rotates around the VOR station. So it may happen that during its rotation, let's, for the purpose of this example, let's consider this is where your variable signal has reached with respect to the VOR station. Okay, variable signal, right? Now the phase difference or the angular difference between this reference signal, between your reference signal and this particular variable signal is 0 niner 0 is 0 niner 0. So we call phase difference is 0 niner 0. That means this particular radial will be radial 0 niner 0. As you can see, here is your reference signal. Over here there is variable signal. Both are away from each other at an angle of 90 degree, phase difference of 90 degree. We call it radial 0 niner 0. Similarly, this variable signal will travel to this side of the VOR, to this side of the VOR. So variable signal, okay, and the angular difference now between this reference wave and this variable one will be how much? It will be 180 degree. The phase difference or the angular difference will be 180 degree, and therefore we call this radial 180, radial 180. Again, in this particular illustration, the reference wave and variable wave are away from each other, or we can call it out of phase with each other. So this way, so on and so forth, we will get many waves or many directions in which the waves are out of phase with each other. But there is one particular direction in which this reference wave and variable wave will coincide or will meet with each other. We call this to be in phase. In phase, meaning both the waves are coinciding. That means this is your reference signal which is fixed in direction. This won't change, but variable signal is going to continuously change. And during this course of change, it will at some point of time coincide with this reference signal. That means it will meet with this reference signal, right? It will meet with this reference signal. Both will coincide, right? So this condition or this phenomenon is called in phase, that both waves are in phase, and this will happen in only one direction, that is northerly, direction 360 or 000. Okay, this will happen only in one direction, that is northerly direction. So the correct option will be option Bravo. Both waves will be in phase in northerly direction. All other directions apart from the northerly direction, these two waves will be out of phase with each other. Even if it is 1 degree, 2 degree, both will be termed out of phase. So this is how you solve this question. So this is based on principle of operation of a VOR, which is phase comparison. A reference signal which is frequency modulated, a variable signal amplitude modulated. Let's go to next question. Question 22, important one. An airway is 12 nautical mile wide. It is defined by two VORs at two ends of it, and both have an accuracy of plus minus 5.5 degrees In order to ensure accurate track guidance within the airway limits, the maximum distance apart for the transmitter. That means the maximum distance between these two VORs should be how much? So let's draw. There is a VOR 1, there is a VOR number 2. Now when you travel from one VOR to another, you fly along a particular radial. You fly on the center line of this radial. But as given in the question, this airway, which is determined by our radial, is 12 nautical mile wide. That means 6 nautical mile on right side and another 6 nautical mile on the left side. Okay. Uh, so let's label this 6, 6, and bearing accuracy. That means the angular difference, angular error between your center line radial and this boundary of the airway is 5.5 degrees. Is 5.5 degrees. And a half degrees. So let's say, like I have explained in the previous videos, when you travel from one VOR to another VOR, there comes a point between them. We call it change over point. We call it change over point. That is, at this place you will switch from VOR 1 frequency to the next VOR 2 frequency. Okay, that will be in the center of this airway, the center location between these two VORs, somewhere there. So I have considered this to be here. So what we will do is we have to find, in this question, we have to find the total distance between these two VORs. So what we will do is we will first focus our attention on this VOR itself. We will find this distance. After finding this distance, we can find this distance and then add both of them. That will give our final answer. So now this is one triangle, right? The angle is 5.5 degrees. This measurement is 6 nautical miles, right? Now we have to find out this x. Now we can do this using tan theta formula. So tan of 5.5 is equal to distance off track upon distance gone. So distance off track is 6. Distance gone we don't know. We have to find that. Tan 5.5 degrees is 0.096. So x will be 6 divided by tan of 5.5, or 0.096, 6 divided by tan of 5.5, which is 62.3 nautical mile, approximately 62. That means this is 62. If this is 62, similarly, this will also be equal to 62. You can make the same triangle on this side, you will get the same answer, 62. So now the total difference is how much? 62 multiplied by 2, which is 124.6 nautical miles. 62.3 multiplied by 2 is 124.6 or 125 nautical miles. So this is how you solve the sum. Main thing is, there is the center line of the airway. This airway 6 nautical mile to the left, 6 nautical mile to the right. That's how wide this runway center airway is. Correction. Marked by two VORs, VOR1, VOR2. The center of that is called change over point, where the change over of frequency happens. And therefore we have found the distance one way, this distance from VOR1. Similarly, that distance will be the same over here. Add them and you get answer 124.6. So option delta will be the correct option. Let's go to question 23. An airway, same question, similar question, which is 15 nautical mile wide, angular difference 5.5 degrees, and we have to find out the maximum distance apart for the transmitter. That means the distance between the two VOR transmitters. So let's draw the diagram directly. This is VOR1, this is VOR2, This is the total distance between them. But we will find the first half distance, and then after finding this half, we will find out the next half and then add both of them. So this is 5.5. The airway is how many nautical miles wide? It is 15 nautical mile wide. So 15 nautical mile wide means over here it is 7.5 mile wide. On this side of the center line, it will be the same, 7.5 nautical mile wide. And now let's find this distance. It will be equal to tan of 5.5, 7.5, which is opposite side, divided by adjacent side. So x will be 7.5 divided by tan 5.5. So 7.5 divided by tan 5.5 is 77.8 or 78 nautical miles. So this is 78. So this will also be equal to 78, this much, right? So this is 78. This entire thing will also be 78. So the total distance between these two VORs will be how much? 78 into 2, which is 156. So the correct option will be option delta, 155. So this is how you do the sum. Same sum. Similarly, both are similar. The technique is the same. Okay. Let's go to the next question. Again, another similar sum. Airway is 20 nautical mile wide. The angle is 5.5 degree. The angle between your center line track and the airway boundary. We have to find the maximum distance apart for both transmitters. So this is your VOR1. This is another VOR. Let's draw a triangle. Now this airway is 20 nautical mile wide. That means 10 nautical mile on either side. The angle is 5.5 degree. And we have to find distance gone. Okay, so tan of 5.5 equals to distance off track or the opposite side of the triangle, which is 10 nautical mile, divided by x. So x will be equal to 10 divided by 5.5, tan 5.5. So 10 divided by tan of 5.5 is 103.8, nothing but 104 nautical miles. So that means this distance is 104. Similarly, this will also be equal to 104. Okay, so the total distance is how much? 104 into 2, which is 208 nautical mile. So option A is the correct answer. Let's go to question 25. An aeroplane flying on a heading of 280 magnetic is on a bearing of 180 degree magnetic from VOR. So now from VOR, a magnetic bearing from VOR is called QDR. So they have indirectly given us QDR 180. If you know QDR, we can find out QDM, which will be the reciprocal of QDR, and it will be 360 or 000. Next, the bearing to the VOR. What is bearing to the VOR called? Bearing to the VOR is nothing but QDM by definition, right? That should be selected on the OBS to centralize the needle is what? So we already know the magnetic bearing from QDR is 180. The magnetic bearing to the VOR is 360 or 000. Now the question has asked us, what should you select on the OBS to centralize the deviation needle? Okay, so now there are two options. This is your VOR, this is your radial 180, and the opposite of this radial 180 is your radial 360. Is your radial 360. Aircraft is on radial 180 currently. So now you can get a center needle, that is a centralized course deviation indicator needle, in two scenarios. If in your OBS selector you put 180, you will get from indication and the CDI needle will remain in the center provided your aircraft is also on the center line of this radial. Or also another option is you can be on this radial 180 and still put OBS setting of 360 or 000. You will get two indication and the needle will remain in the center provided your aircraft is on the center of this radial. Okay, so there are these two possibilities, these two settings that you can do in the OBS. Now the question has explicitly asked us for the bearing to the VOR, bearing to the VOR. Now when you put radial or setting of 180 in the OBS, you get a from indication. That means you will be flying away from the VOR. Whenever you are flying away from the VOR, you tend to fly away from the VOR, you put this radial 180 so that you get from indication and a normal sensing of the CDI needle. If you are flying on this radial 180 but towards the VOR or inbound towards this VOR, the correct procedure is to put 360 so that you may get two indication and the normal sensing of the CDI needle. Okay, so depends whether you're flying inbound or outbound. A radial takes you outbound, a course takes you inbound. So over here they are asking for bearing towards the VOR, meaning QDM, or you're flying inbound. So that will be what? 360 or 000. So the correct option will be option A, option number A. Question 26. An airplane flying on a heading of 280 magnetic. Now here again, like previous question, the magnetic heading of a VOR is irrelevant to magnetic heading of an aeroplane, correction, is irrelevant to VOR because VOR is only concerned about aircraft position. Okay, the position on its radial. You can be heading in whatever direction. What matters is the your position with respect to the VOR radial. So ignoring a heading of 280, the next information is a bearing of 180 magnetic from VOR. Okay, from VOR means QDR is 180. If QDR is 180, QDM will be 360 reciprocal. So now you have to select an OBS with a bearing from the VOR. In the previous question, we selected an OBS setting which gave us a bearing towards the VOR. Over here, we have to select a bearing from the VOR. That means a setting which will take us outbound or away from the VOR. So the correct option will be same. My explanation is going to remain the same. If you intend to fly away from the VOR on this radial 180, correct procedure to get normal sensing of CDI needle will be this. Put 180 OBS setting so as to get from indication. If you are flying inbound, put 360 so that you may get two indication. Okay. So over here, the setting that you will select will be option Bravo 180 since you want a bearing from the VOR. Okay. Proceeding to question 27. VOR is at position 66° north, 25° east, and aircraft is at 56° north, 25° east. So that means VOR is directly to the north of your aircraft. VOR is directly to the north of your aircraft. So if VOR is directly north of your aircraft, that means aircraft is on radial 180 from VOR, but this radial will be true in direction. This is not your final answer. Now all radials of VOR are magnetic. To obtain a magnetic direction, you need to take help of variation. Variation is nothing but the connecting link between your true direction and magnetic direction, right? So true, variation, and magnetic. So what is true? It's 180. Now variation. In case of VOR questions, we will use VOR available at the VOR station, not your aircraft. So estimated pulse. So variation at aircraft location is 25° east. Disregard that. Variation at VOR is 20° east. So use this variation. So 20 east. Now next step, variation east, magnetic is least, meaning magnetic direction will be less than true direction. So 180 minus 20 will be 160. So the correct answer will be aircraft is on a radial of 160 from the VOR. So select the option A, 160. Let's go to question 28. Similar question, airway 10 nautical mile wide, the angle 5.5 degree, and you have to find the distance between the two VOR transmitters. So let's save time. So I will draw just one VOR. I will find this distance. This will be 5, right? Since the airway is 10 nautical mile wide, it will be 5 nautical mile on both sides of the center line. We will find this distance. We know this is 5.5 degrees. So tan of 5.5 degree is equal to opposite side of the triangle, which is 5, divided by adjacent side, which is x. So 5 divided by tan of 5.5 will be equal to how much? 51.9, approximately 52 nautical miles. So the distance from one VOR is 52. The distance from the second VOR, the another VOR will be the same, 52. So now the total distance between these two VORs will be 52 multiplied by 2, which is equal to 2 5s are 10. So 104 nautical miles. So option B will be the correct option. 105, the closest. Okay, so I have not done this in detail because I have already done it previously twice. So this is how you do it. Just the triangle, the angle, distance off track, distance gone. You can do it with 1 in 60, or you can do it with tan theta also. Always select the closest option. Let's go to question 29 now. Aircraft is required to approach a VOR. That means it is required to fly towards a VOR or inbound towards a VOR, right? On radial 104 degree. 104 degree. Which of the following settings should be made on the OBS selector? So let's draw the VOR. This is your VOR station. This is your north datum. This is your radial 104. And now there are two possibilities again. You can fly on this radial 104 and go outbound. Okay, in that case, what settings will you do? You will put 104 here. You will get a from indication. But in this question, it is stated that you are flying towards the VOR. You are flying towards this VOR, right? So in that case, what settings will you put? This is your OBS. You will put the reciprocal of 104, which is 284, radial 284. So you will put 284 in the OBS setting. That way you will get a 2 indication. Okay. Since you are flying towards the VOR, its correct procedure is to put 284 setting, which will be the setting which sooner or later you will be transitioning to. Because if you continue flying towards the VOR on radial 104, what will happen? You will fly towards the VOR. Very soon you will be overflying this VOR station and then transitioning to the next reciprocal radial, which is radial 284. And now you will be flying in the same direction but uh, towards 284 direction on radial 284. So when you do that transition, this to and from will become from. Okay, everything else will remain the same. 284 will remain the same. If you are maintaining the center line of the radial, the CDI needle will also remain in the center. Only the to and from flag will change and it will become from. as soon as you transition from this side of the VOR to this side. Okay, so you have to read the question carefully. They have asked us about approaching, that is inbound setting. So inbound will be 284, and when you put that, you will get a 2 indication. So option Bravo is the correct answer. Question 30. Aircraft is on a heading of 280, is on a bearing of 090 from a VOR. So a magnetic bearing of 090 from a VOR means QDR is 090, or you are situated on radial 090. Okay, the bearing you should select on the OBS to centralize it with a 2 indication. 2 indication means magnetic bearing towards the station. We call it QDM, which will be reciprocal of QDR, which will be 270. 270. So now you have the answer, but still I will explain it diagrammatically. This is your VOR station. This is your north datum. Now aircraft is on what radial? It is on radial 090. So let's draw this radial 090. Okay. The opposite of it will be radial 270. Now you want 2 indication. The question states you want 2 indication. So now there are 2 possibilities. You know that you are on radial 090. Now there are 2 settings that you can do in the OBS. The first one is you can put radial 090. In that case, radial takes you away from a VOR, so you will get a from indication. And you can also do 270 setting, being on radial 090 itself, 270 OBS setting. In that case, you will get a 2 indication. So if you are flying inbound, you put 270, you obtain 2 indication. If you are flying away from the VOR, you put 90 and you get from indication. So the correct answer will be 270. If you want a 2 indication, you put 270. If you want a from indication, you put 090. With this question, we have come to the end of this productive lecture, and I hope you have understood all the 10 questions we have done today. I also suggest you all to do the previous questions that I have